says, what is the gravitational force between a proton in a hydrogen atom and the electron in a hydrogen atom? And then it gives us their masses, if they are, and then it gives us the distance. So let's talk about this for a second. I went in here. This is an electron, right? And then this big circle here, because protons are way more massive. This right here is the proton, right? This whole thing. Actually, I should probably do, let's undo that. Let's do this. All right, so this is a positive charge. This is the proton. Whoops. All right. So then what does that tell me? Well, it says that the proton has a mass. The mass of the proton is equal to 1.7 times 10 to the negative 27 kilograms. All right, so that's in kilograms. That's good. And then that my mass, we'll do it like this. The mass of the electron is equal to 9.1 times 10 to the negative 31 kilograms. So they're very small items. Okay? And then it tells us that the distance between them, this distance here, and really technically, if I want to be really technical, the distance goes from the center of this object to the center of this object. Well, that's the radius of the circle, right? So that is 5.3 times 10 to the negative 11. So then what do we do with this information? Well, remember that when we want to calculate, well, there's a couple ways you can calculate gravitational force, but the one formula that we're going to use a lot of in this section is capital G, and I like to write the capital G on the top. It just makes my life a little easier. And then the two masses multiplied by each other, because we're calculating between two masses, and then the distance between the two. Okay? So then my gravitational force, and sometimes you'll see it in textbooks like this, force due to gravity, they do the little subscript G. This is going to be that same constant, 6.67 times 10 to the negative 11 times the mass of the first item, which is the proton, which is 1.7 times 10 to the negative 27 times the mass of the electron, which is 9.1 times 10 to the negative 32, or 31, sorry. I'm reading ahead here and it's throwing me off a little bit. And then the distance between them is 5.3 times 10 to the negative 11. 5.3 times 10 to the negative 11. So let me just double check all that, make sure that I put all my numbers in correctly. Let me read this question again because they have a different number written down than I do. Well, we're going to find out if we're right or not because I think I have everything written down, but as I'm reading the solution, they've got a bunch of wonky information in here. So I think they typed it wrong. Let's see what it is. There might be a typo. So I'm going to, in the top part, put 6.67 times 10 to the negative 11. And then you got to leave the superscript, hit times 1.7 times 10 to the negative 27. Leave that, hit times. And then 9.1 times, yeah, it's weird. They got the wrong thing written down. Raised to the negative 31. And then on the bottom, we've got the distance between the two of them is 5.3 times 10 raised to the negative 11, wasn't it? Yeah. To the negative 11. And I'm going to put that in parentheses because I'm going to square it. Yeah. So that's the right answer right there. Interesting. So when I hit enter, bless you, my solution manual had the wrong numbers written down but the right answer. So it's 3.67 times 10 to the negative 47. That's a very tiny amount, but it's enough. Yes?
Yeah, 6.67, is it meant to be outside of the fraction or in the fraction?
You could put it on the outside of the fraction, but I like to just put it on the top. Mathematically, it's the same. It just makes it a little easier for me to plug it in the calculator. Mathematically, it's the same. All right, so then the question was, in the original formula, we have G usually in the front. Well, some formulas have it in the top, but mathematically, this is the same as. Why is that not letting me write? Okay, this is the same as this. Either way would work. But back to the answer, we've got 3.67. Uh-oh. My thing is going wonky. Times 10 to the negative 47 newtons. And that's it.